So in which step, A, B, C, or D is work supplied? Okay, so what we want to do actually for each step is figure out work and heat. Okay, so in which step, A, B, C, or D is work supplied? Okay, so I'll let you think about that for a short period of time, and if you think you have an answer, you can discuss that with the person next to you, see if you come with the same answer. If you and the person next to you came with the same answer, that's great. If not, then you can resolve your conflict peacefully. Okay, so in which step, A, B, C, or D, is the work supplied to the refrigerator? Who says it's A? Who says it's B? Who says it's C? Who says it's D? Okay, now, if you look at this diagram here, see this little thing here is supposed to be a little piston, and that's going to represent the mechanical compressor in the refrigerator. So when your refrigerator turns on, that's the compressor turning on and compressing the low pressure gas into a high pressure gas. So it's actually step A where the work is supplied. Okay, so for step A is work greater than 0 or less than 0? So this is going to be greater than 0. Now remember that work is equal to minus P times delta V. So in this case here, when a low pressure gas is compressed to a high pressure gas, is delta V going to be greater than 0 or less than 0? Because the delta V, because of the compression, is going to be less than 0, which means that work is going to be greater than 0. Is Q for step A going to be greater than 0 or less than? In other words, is it exothermic or endothermic? Okay, so when a gas is compressed, does the temperature of the gas change? So what happens to the temperature of the gas as it's compressed? Does it increase, decrease, or stay the same? Increase. What? Okay, so it increases. So if it increases, that means that in here, the temperature is increasing. Now, for Q has to be, heat has to be transferred from the system, which is in here, to the surroundings outside the system. So if the temperature of the gas increases, is heat can be transferred in here to outside in the environment, or the surroundings. So I guess you could say, well, if this is a good heat conductor, the tubing where the refrigerant is contained, if this is a good conductor, will heat be transferred from the inside to the outside if the temperature in here is higher than the temperature outside? Yeah. Okay, so if it's a good conductor, heat will be transferred. If it's a good insulator, heat will not be transferred. So it sort of depends on whether you claim it's an insulator or conductor. So what do you want to say? Insulator or conductor? So you'll say that if that refrigerant tubing is a conductor, heat is going to be transferred. So is Q can be greater than 0 or less than 0? So is the system gaining heat or is it losing heat? So it's losing heat, that means Q is equal to, greater, equal, or less. Let's go to part B. So a high pressure gas converted to a high pressure liquid. Yeah, so note this is a phase change. So what is this phase change called when a gas is converted to a liquid? Yeah, this is condensation. So when a gas condenses, is heat removed or does heat have to be supplied? So if heat is removed, is Q greater than 0 or less than 0? So you're saying that condensation is an exothermic phase change process. Do you agree? Okay, so I'm not going to write anything down until I see your eyes no longer being glazed over. Maybe it was that big Krispy Kreme donut you had this morning with a cup of coffee. Now you need to take a nap since it's what, 10 o'clock? Yes, you had your donut at 8 o'clock this morning. It takes a few hours for that digestion to occur, and now you need all that blood is rushing from your brain to your stomach, and then you need to take a nap. So that can be your excuse for not taking the class at 10 o'clock. Okay, so it's Q greater than 0 this time. Okay, that's why it's 0. Okay, so again, condensation is an exothermic process. Now, is work can be greater than 0 or less than 0? How do we know it's greater than 0?
It takes work to change the state.
Yeah, so if work is greater than 0, that means that the environment or the surroundings has to supply work to the system. If work is less than 0, that means that the system is producing work to the surroundings. Okay, so when a gas condenses, we have a gas going to a liquid. So we can do with this the same thing we did on Tuesday. So what's delta N going to be? The change in the moles of gas. Yes, so then we have 0 moles of gas products, 1 mole of gas reactants, so delta N in this case is going to be greater than 0 or less than 0? Less than 0, which means that delta V is going to be less than 0, which means that the work is going to be greater than 0. Okay, so we did 2 examples together, so I'd like you to do C and D. And then I'll have a volunteer come up to the chalkboard so they can see themselves on that YouTube channel and see how they feel about it. seeing themselves on the World Wide Web. Whether it's in the liquid or gas, it stays continue to supply refrigerant to the refrigerator. I was trying to figure out a way to raise one part of the refrigerator. Oh, see, this depends on the temperature of the boiling point of the refrigerant. That's why you choose the refrigerant. You choose the refrigerant. Which has that will determine how cold